In today's lesson, we will look at a third method that can be used to solve a system. The first two methods we looked at were graphing and substitution. We could graph two lines and find where they intersect simply by looking at the picture. We also used the method called substitution, where we could substitute what a variable was equal to, and we could find the solution that way. Now there's a third method that we're going to learn. This method relies on us eliminating one of the variables. So this method is called elimination. In the elimination method, we are working to be able to eliminate, to be able to get rid of one of our variables. And so as we begin this method, the first step is always to rewrite the two equations so that we can line up our like terms. So, for example, I'm going to take the first equation and I'm going to leave that as negative 3y plus x equals negative 4. But then this second equation, I'm going to rewrite it. I'm going to put the negative 2y under the negative 3y. I'm going to put this negative x underneath the x in the top equation. I'm going to line up my equal signs, and then I'll put the negative 1 here. Once I have aligned both of my like terms, so the y's are in line with y's and x's are in line with x's, I'm going to look at the equation and I want to eliminate one of the variables. When we eliminate a variable, we have to decide whether to add or to subtract the two equations. So let's think about that. If I were to add the two equations together, negative 3y plus negative 2y is negative 5y. 1x plus negative 1x is 0. That would eliminate my x's. So I'm going to add on this first one. Negative 4 plus negative 1 is negative 5. Now I can solve for y. I can divide by negative 5 on both sides. And I find out that y equals 1. Remember, the solution is always an ordered pair. So we now have the second half of the ordered pair. We know that the y-coordinate is 1. Now, we need to solve for the other variable. So we need to take what we know. We know that y is 1, and we need to plug that into one of the equations. It does not matter which one you choose. I'm going to choose the top one, negative 3. Instead of y, we're going to fill in 1, plus x equals negative 4. Now let's solve. Negative 3 plus x equals negative 4. We can add 3 on both sides, and we come up with the answer of x equals negative 1. That's the second half of our ordered pair. That means our solution is negative 1, 1. These two equations, if we graph them on a coordinate plane, would cross at negative 1, 1. Now, we can certainly check our answer by plugging that back into one of the original equations. So I'm going to plug it back into the top one again. I'm going to plug in negative 3. Instead of y, I'll fill in 1. Plus, instead of x, I'll fill in negative 1 equals negative 4. Let's see if that's true. Negative 3 plus negative 1 equals negative 4. Is that true? Yes. So we know our solution is correct. Let's try another example together. So let's begin by rewriting our equations. I'm going to leave the first one as is, negative 5x minus 4y equals negative 30. And then I'm going to take the second one and line up my variables. So I'm going to move this positive x underneath the x terms. I'm going to move this positive 4y underneath the y terms. And I'm going to move my equal sign and my negative 10 underneath the final term. Now remember, in the second step we have to decide whether we add or whether we subtract. I typically check addition first. Nothing special about that, but that's typically my pattern, so I'm going to check addition first. Negative 5x plus x is negative 4x. Negative 4y plus 4y is 0, so I've eliminated my y's. Negative 30 plus negative 10 is negative 40. Now let's solve for x. And we find out that x is equal to 10. That means the first half of my ordered pair answer is 10 something. Now, let's solve for the other variable. Let's take our answer and let's plug that back into one of the two equations. Again, it doesn't matter which one. I'll use the bottom equation this time since last time I used the top. Negative 10 equals, instead of x, let's fill in 10 plus 4y. To solve, we're going to take away 10 on both sides. So we have negative 20 equals 4y. We divide by 4 on both sides, and we find out that y is equal to negative 5. So now I have the second half of my ordered pair. So I'm saying the solution to this system is 10, negative 5. We can check that. Let's plug that into this top equation and see if it works. Negative 5 times 10 plus, oh, that's not a plus, let's make that a minus instead, minus 4 times y is negative 5, equals negative 30. Now let's check our math and see if that's right. Negative 5 times 10 is negative 50, minus 4 times negative 5 is negative 20. I notice here that I ended up with two negatives in a row, a minus and a negative, so I'm going to go ahead and make that plus positive. Negative 50 plus positive 20 is negative 30, and negative 30 does equal negative 30. So my solution works. 10, negative 5 is correct. We're going to stop the video here. Example 3 and example 4, which follows, we will be working through together in a small group in class. I do want to mention that if you continue to scroll through your notes after example 4, there is a page that lists all of the steps to this elimination method. Feel free to use that as you're working in class or working at home as a reminder of what the steps are in case that might be helpful to you.